Hi, my name is Danna Gurari, and I'm going to spend the next 25 minutes talking to you about my team's work on visual question answering with a focus on the challenges and opportunities for a real-world application. So to set the stage, the task we're talking about, of course, is visual question answering. So given an image with a question about the image, the goal is to return an answer, such as questions of, is this shirt clean or dirty? Hi there, can you please tell me what flavor this is? Or is it edible or poisonous? A primary motivation for this task is the observation that real users at present and for the past decade have been relying on visual question answering services for supporting their on-demand real needs. So from the inception about 10 years ago, when the first application came out for this purpose, it was a mobile phone application that allowed a user to take a picture, then record a spoken question, have those sent off to some online crowd who would then provide an answer. Of note, there's an estimated 39 million people worldwide who are blind. And so this application really can have far-reaching effects for one real use case scenario where visual question answering matters. A commonality for the applications that have emerged since that application I described 10 years ago is that there's a reliance on remote workers. So whether we look at the original VisWis application through present applications, a commonality is that it's going to be humans who are providing the answers to the visual questions. Of note, some of these applications not only rely on mobile phone applications, but also have moved on to relying on cameras put on glasses. And so there are different flavors of how this task can be deployed for real users. Again, the commonality, though, is that humans typically are the ones who are supplying the answers, and humans have many drawbacks, including that they can be very costly, they can be slow, and there also can be begged some privacy issues of some strangers looking at data coming from real users. So one of the aims that our team has been looking at is figuring out how to teach computers to automatically answer visual questions asked by real users, in our case, people who are blind. To set the stage for what I'm going to present, I just want to go over the typical computer vision pipeline today. At present, the pipeline starts typically with creating a large-scale data set. Then next comes the design, training, and evaluation of algorithms using that data set. And after the satisfaction with how that algorithm is doing, then the algorithm can be deployed for real users. And so in this presentation, I want to talk about three key challenges with this pipeline. One is that there's often a dataset mismatch for real users' needs. Another is that there's also often an algorithm mismatch from dataset challenges. And the third is that real users' data can reveal new problems. So diving into the first, which is the dataset mismatch for real users' needs. Here I show examples of three visual questions that embody what's typically seen in prior visual question answering datasets that the community has been working on, as well as visual questions from real users in the bottom row. In the case of prior work, the status quo has been that the picture and the question have been collected independently. Typically, the pictures are downloaded from the internet, and typically someone else is employed, often crowd workers, to look at the image and come up with some sort of question. In contrast, in a real use case, it's the same person who both takes the picture and asks the question, and the data reflects real users' interests. So real users, as exemplified here, they can ask questions like, can you please tell me what flavor this is? What temperature is my thermostat set to? And do my speakers match? Just to further emphasize this mismatch between the data sets of real users and prior work, we did do some work where we looked at whether or not a classifier could predict which data set a visual question comes from, and we found that a classifier with 99% precision and recall is able to identify whether a visual question comes from real users versus from existing data sets that were contrived. And so with all this in hand, we embarked on creating a large-scale data set that originates from real users to represent their real-world needs. And the starting point for this work is actually the data that came from the application I described, the VisWiz application that was introduced in 2010. At the time, between 2011 and 2015, over 11,000 people used this application to submit over 70,000 requests. We used almost 45,000 of those, or 62% of the requests, from which users agreed to share their data. In order to package this data set for the community to work on, we had to make sure that we took care of the privacy of all users who submitted their information. And so we took a number of steps in order to do that. First, we transcribed all questions to remove people's voices. We also resaved all images to remove metadata such as their location. We also filtered out any sort of personally identifiable information. So if an image had it, we would flag that image as having personally identifying information, and in order not to publicly release those images as is. And we came up with a taxonomy of what is personal information or private information, and that included things like people's faces, medication information, as well as information in their mails, such as their addresses, social security numbers, financial information, and more. With all that done, we took the non-private data and sent that out to the crowd for annotation to deliver high quality answers to the visual questions that were asked. The result of this effort is over 32,000 visual questions with 10 answers per visual question, or almost 330,000 answers. This was the first data set where real users requested answers to their visual questions to support their real daily needs. And in exploring what do real users, what happens in this data set from real users, we did quite a bit of analysis, and I'll just touch on some of the high level points. First, I show the most common objects found in their images. Often you'll see people are trying to learn about daily objects, such as packages, containers, things on their computer, food, things on their screen, and you'll see things like table, because often put some package on a table, take a picture, and so the table ends up being as part of the content. In terms of questions, we also looked at what's the span of questions look like, and we found that the most common question is, what is this? We also saw that common questions included, what is in this can? What does this say? And what color is this? Many questions also begin with a rare word. So people had been quite conversational sometimes with providing their visual questions, and would start those with things like hi, please, and okay. We also looked at what were the most common answers. Of note, in what I'm showing, the size of the word is proportional to the frequency of that answer in the data set, with the exception that we did exclude from this visualization 29% of the visual questions that are deemed not answerable. And so if you look at what are the kinds of answers that are seen, we often see yes, no, as well as colors such as black, white, gray, and red. The items you won't see are very rare answers, such as strings that are seen in a CAPTCHA, for example. We have publicly released a visualization tool where you can actually browse this data set. So here you can expand on a summary of images to see a sample of 50 images per batch. You can then click on any one of those images to see more information about it. The visual question, the answers, as well as other metadata that we have collected to date. That includes captions that describe the contents of the image. And so we encourage you to jump onto this, this particular browser at visviz.org if you're curious to learn more about their images and questions that are being asked. So we kind of come up with a data set to address that there's a data set mismatch between real users' needs and the algorithms that are being deployed for real users. The next thing we want to look at is the algorithm mismatch from Dataset Challenges. So just to recap about how do we evaluate these algorithms and their suitability for the existing data sets. And so we start with typically an image, question and answer for a bunch of visual questions. And we split that data set into a training set and a test set. We train the algorithm on some training set to minimize prediction error on it. And then we take that trained model and we apply it to our test data. And we look at how well those predicted answers match or do not match the actual true answers. And so we explored this in our initial work in 3 different cases. One case is we looked at pre-trained state-of-art algorithms. What do I mean by pre-trained? I mean where the algorithms are trained on the, at the time, state-of-art, it was the most popular data set at the time, the first version of the VQA data set from Antal et al. In 2015. We evaluated 3 different algorithms, and in general, you want to see scores that are closer to 1. Scores are pretty low. The gist is the algorithms perform very poorly. We next evaluate those algorithms where we trained all those algorithms from scratch on a new data set to see if the problem was the training data, not the algorithm architectures. And so in this case, we trained on the data we had collected that was taken by people who are blind. Yet again, we found the algorithms perform quite poorly. So this tells us that not only is the data problem, the algorithms are the problem, potentially. And so we examined one final use case because our data set is relatively small, where we used the algorithms that were initially pre-trained on that VQA 1.0 data set, and then fine-tune those algorithms to our new data from people who are blind. However, we again did not see much improvement. Okay, so at the time we found algorithms perform poorly. Why might that be? We had done quite a bit of research to try to detangle what's different, what makes this data set hard. We've found a number of challenges which we have put into various papers that have come out and are still coming out. One of the challenges is that many images are low quality. So we actually have asked crowd workers to label which images are low quality and what are the quality issues that are arising. And in summary, we found over 50%, roughly half of the images have some sort of quality issue. We also tried to figure out how many of these images contain text, and we found that about 63% do contain text. And finally, we found that these images contain many novel concepts that are not seen in other data sets. And so we see things like thermostats, CAPTCHA, currency, progresso apparently is a popular topic in this data set as well for the food bring-out. Other challenges that we attribute the algorithm performance to is that many of the questions seek a different pool of vision-based skills from what prior work sought. So what's shown in this figure is categorization of 4 different kinds of skills: object recognition, color recognition, text recognition, and counting. And we show an example from the real blind users, which is the first row, with questions such as, what is this? Does it look clean? When does this expire? How many pairs of shoes are on the floor? As well as comparable visual questions in the VQA 2.0 data set that's popularly used in the vision community. And we labeled all the visual questions in the VisWis data set, as well as a sample from the VQA 2.0 data set to see how do the skills, how similar are they? And what I show here is the result, both in terms of what percentage of the visual questions involve those skills, as well as what were the popular questions that were asked with respect to those visual questions that involve those skills. And just at a high level, what did we find? We found that the prevalence of needing object recognition and color recognition is similar across the two data sets. So object recognition is pretty much a prerequisite required skill, being needed for over 90% of visual questions in both data sets. Color recognition is less common, accounting for about 20, almost a quarter of the visual questions in both data sets. And we see that the most popular questions, for example, for color is, what color is this in the VisWis data set? Whereas, again, what color is this within the VQA 2.0 data set? So there's definitely some overlap, but where we see the key difference is in the visual questions that require text and counting. For the case of text, we see that for images taken, for visual questions asked by people who are blind, almost half of the visual questions require reading text. And we find that that's not the case for the VQA 2.0 data set. It's a much smaller percentage. And similarly, we find within the VQA 2.0 data set that the skill of counting is very common. So, over 16% of visual questions for VQA 2.0 involve counting. In the case of images taken by blind users, it's rare. It's less than 2% of visual questions that require that skill. So just to exemplify some of these skills in the VisWis data set, from the 46% of questions that involve reading text, these are just a few examples where people ask, could you please tell me what's in the can? What are the directions for someone who's 10 years old about a medication pill bottle? And for an image showing a screen of what appears to be a Microsoft licensing terms, the question is, do I have to hit anything? Any key combination to make it work? For examples regarding the 28% of questions that involve recognizing color, examples include, is this shirt clean or dirty? What color is my shirt? And does the pant and the shirt match, and can it be worn together? In order to accelerate progress on this important problem that can really change the lives of real users, we have shared our dataset publicly. And so if you go to viswis.org, you will find a tab for visual question answering under tasks and datasets where you'll learn more. Others also are sharing this data set. So it's been also released on academic torrents and Kaggle, as well as Facebook's platform, if you're looking for other places to download and employ the data set. And we also have been tracking progress on public evaluation servers with leaderboards. And so you can follow, if you choose to partake in this challenge, where you stand in the international stage in terms of developing algorithms for this problem. And of course, we're including the Dataset Challenge that I've spoken of in this workshop to encourage and celebrate progress. And the progress has been celebrated across the world with people writing articles, as well as posting about their success on our challenges, as well as their excitement about the data set in various social media platforms. So if you are interested in it, if you're interested in joining, here's how it works. We have split the data set into a training set and a test set with the target responses for the test set hidden from you. Design an algorithm and submit its predictions on the test set to Eval AI. to do this, and I'm happy to field any questions after this talk. Feel free to contact me about how to get involved. So I want to conclude with looking at what are the real users' data, what new problems does the real users' data reveal? So again, if we think about the pipeline we started with, where a user submits an image and a question, and then an answer is returned from humans. What we find from this particular use case is that 9% of almost 40,000 images have some sort of quality issues that lead those images to be too severe to recognize the content. And in this slide, I just exemplify some images and how it manifests, how images appear when it's hard to really figure out how to identify what is the content in the images. Another related challenge is that 29% of the submitted visual questions are not answerable. So questions such as, what is expiration date? What is this gift? What is this a gift card for? What temperature is the dial set to? All those were missing the answer within the image. And finally, as I mentioned earlier on, when we were building this data set, we tried to remove all the private information that we found. We found that 12% of submitted images show private content. This could include content such as people's faces, their credit card numbers, their pregnancy test results, information on computer screens, as well as information about their prescription pills, and more. And of these privacy disclosures, over half were intentional. Lots of times, private information can be inaccessible to people who are blind, and they took the trade-off of compromising their privacy in order to learn about their private visual information. So these insights helped us identify a number of new problems with dataset challenges that we share with the community. First, given an image, decide whether the content can be recognized. Second, given a question about an image, decide whether it can be answered. And third, given an image, decide whether it contains private content. So we encourage you, if you're interested in any of these problems or more, we encourage you to get involved to help accelerate progress, to support these needs that really stem from real users today. So that concludes what I wanted to present today. Again, we talked about the issue of the dataset mismatch for real users' needs. We talked about the issue of the algorithm mismatch from dataset challenges, and also new problems that emerged from real users' data. So I'll leave you with some thoughts about where we think this work helps the community. We believe our new dataset challenges empower the AI community to work on real use cases. Our algorithm analysis reveals open technical challenges for the AI community. And our dataset analysis reveals new important AI problems for supporting real users. I'd like to acknowledge the many people involved in the work I have presented. This includes many of my mentees whose images are shown in the upper right corner, as well as colleagues I've had over the past several years. And finally, there's been a lot of support from the community in setting up this VisWis Dataset Challenge, including from those who set up the VisWis application, as well as support in getting the crowdsourcing task code and evaluation server set up. And then lastly, I'd like to comment on the over 3,000 crowd workers who have spent tens of thousands of their hours to help make these data sets possible. This work was also in support with funding from Microsoft, NSF, and Amazon. So I'll leave you with the invitation to join our dataset challenges to try to figure out how to make more generalized algorithms that include addressing real users' needs. And I hope you can join us at today's question and answering panel. Thank you for your time.